Recording in progress.
Okay. In general, with Gram-Schmidt, we've replaced dot product with inner product because we know, for example, in function spaces, an inner product can be defined by an integral. It's not a dot product. And the idea of perpendicularity becomes orthogonality. Orthogonality being defined by the condition that the inner product is 0. So we don't literally have the 2- and 3-dimensional picture anymore. But everything that we do with Gram-Schmidt can be done. So if we have given basis V1 through Vn, okay, let W1 equal V1 over the magnitude of V1. Now, I just tried to take a look at your book because I don't pay that much attention to notation. I think the notation your text uses for general inner product is pointy braces with the 2 vectors, okay? And here it would be square root of this inner product. So there's your W1, then W2, well, U2 equals V2 minus the projection of V2 onto V1, which, because V1 onto W1, since W1 is a unit vector, that projection is just V2 W1 inner product times W1. And then let W2 equal U2 over, I keep wanting to write magnitude, and I could, because the magnitude is defined to be the square root of the inner product of U2 with itself, but I'm going to write it out explicitly. Then U3 equals V3 minus V2 W1 times W1 minus and it's V3, not V2. Remember, these projections simplify due to the fact that W1 and W2 are both unit vectors. So now W3 equals U3 over the square root of the inner product of U3 with itself. Maybe a little hard to read, but there it is. And then U4 would equal V4 minus the inner product of V4 with W1 times W1 minus the inner product of V4 with W2 times W2 minus the inner product of V4 with W3 times W3, and I'm not going to write it out, but W4 would then be U4 divided by the magnitude of U4. And that's it. Okay, so we generalize this to any inner product. It doesn't have to be a dot product. It doesn't have to be a Euclidean space. Any vector space. We've got a basis. We can convert it to an orthonormal basis. Okay. One other thing, we're doing WebAssign here. And WebAssign sort of drives me nuts. I'm using the standard WebAssign assignment, which I think is a little bit too trivial. But if that's the conventional wisdom, since this is the first time I've done WebAssign for this course, I'm going to go with it. But it drives me a little bit nuts when you have multiple opportunities on a problem and you have two choices. Okay? So I will be asking from now on in this course that you submit your written work on any assignment. Okay? In the same way you submitted written work on other assignments. That isn't necessarily an official assignment until I write it out, but believe me, I'm going to do that soon. Okay? I want to see your written work. I want to see your reasoning. If you have a true or false, I hate true or false questions, and you have so many of them in WebAssign. They don't make you think through anything. You just guess, and then, it didn't work, I'll guess this. And I can't eliminate guesses because on some problems you need a couple of opportunities, okay? You need to be able to revise a small error. So I'm not happy with that aspect of WebAssign. Anyway, I want to see the written work. Okay, you get credit for your homework, but if you don't learn anything, you don't pass the test. I want to see it so I can help you prepare what you need to do in order to pass a test. Okay, so please get in the habit of doing that from now on. Okay, thank you. Good luck.